Hello everyone, this is Shravan Sir making maths simple for you. Welcome to my YouTube channel Karna Maths Academy. Today's topic is area of triangles and quadrilateral, which is from class 10 compulsory mathematics. Dear students, today in this video we are going to discuss one of the most important question, which is the out theorem from the area of triangles and quadrilaterals. Here we go. Dear students, the question is, in the given figure ABCD is a parallelogram. Prove that triangle APD plus triangle BPC is equal to half of parallelogram ABCD. Dear students, in this question we are given a parallelogram ABCD and we have to prove that the triangle APD plus triangle BPC is equal to the half of the area of the parallelogram ABCD. So dear students, at first we have to show the relation of triangle APD with the parallelogram ADYX, or we can say AXYD. So dear students, the figure AXYD is also a parallelogram, because in the figure the opposite sides are given parallel. So at first we will take the relation between the area of triangle APD and the upper parallelogram AXYD. So let's write down the relation. We know that the area of triangle APD, we are going to take the first triangle APD. Area of triangle APD is equal to half of the area of parallelogram AXYD. Parallelogram AXYD. By using theorem 2, we can write area of triangle APD is equal to half of the area of parallelogram AXYD. The reason is the area of triangle is half of the area of parallelogram standing on the same base and between the same parallel lines same parallel lines. So dear students, we have got the relation between the area of triangle APD and the first palm AXYD. Now we are going to write down the relation between the second triangle BPC and the lower parallelogram BCYX, or we can say XBCY. BCYX. So BCYX and triangle BPC, they are on the same base BC and between the same parallel lines BC and XY. Same as the statement number 1. Same as the statement 1, we can write down the relation between triangle BPC and the parallelogram XBCY. So let's write down statement number 2. In statement number 2, dear students, in statement number 2, we can write area of triangle BPC. Area of triangle BPC is equal to half of the area of parallelogram XBCY, the lower parallelogram XBCY. The reason is same as the statement 1, same as above, or we can write same as the statement 1. The area of triangle is half of the area of parallelogram standing on the same base and between the same parallel lines. Dear students, now in the statement number 3, so according to the question, now we have to add the area of triangle APD and area of triangle BPC. We have to take the sum of the area of two triangles. So let's add statement 1 and 2. So by adding the statement 1 and 2, we get area of triangle APD plus area of triangle BPC. Area of triangle APD plus triangle BPC. So dear students, by adding the statement 1 and 2, we get the statement 3. Now if we add LHS, then we get the sum of the area of two triangles. Now if we add RHS, then we'll get the sum of the area of two parallelograms. So half we can take common while adding. Now if we take half common, dear students, now if we take half common, then we get half into area of palm AXYD, palm AXYD plus the second palm is XBCY, palm XBCY. So dear students, we have got the statement 3 by adding the statement 1 and 2. Now next statement, dear students, now statement number 4. Dear students, now the reason we can write, the reason for statement 3 is adding, the reason for the statement 3 is adding statement 1 and 2. So dear students, by adding the statements 1 and 2, we get the statement 3. Now from this statement 3, now we'll get the statement 4, and that will be the proof of our theorem. So dear students, now let's keep the LHS side as it is. Let's write down the same, because we need triangle APD plus triangle BPC. So area of triangle APD plus BPC. So two triangles. Dear students, the LHS side we have written as it is, because we need the sum of the area of two triangles. Now dear students, we know that by the whole part exam, if we add part, then we'll get the whole. If we add part, then we'll get the whole thing. So dear students, if we add the two parallelograms AXYD and the parallelogram XBCY. So let's look at the diagram. If we add the parallelogram AXYD and the parallelogram BXBCY, then we'll get the whole parallelogram ABCD. So this is called whole part exam. If we add part of any figure, then we'll get the whole figure. So dear students, now we can write the sum of the two parallelograms AXYD and XBCY. AXYD and XBCY. If we add upper parallelogram and lower parallelogram, then by adding we'll get the whole parallelogram. So we can add area of parallelogram ABCD, and this is the proof of our theorem. That means the proof of this question. So the reason is by whole part exam. Whole part exam. So dear students, we have got the sum of the area of two triangles APD plus BPC. We have got equal to half of the whole parallelogram ABCD. So dear students, I hope you have understood how to prove this our theorem. Thanks for watching this video. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.